All right, guys, so this is part B of the question that I did in the previous video. And it requires us to find the area of this purple shaded concrete path and the value of x such that the area is a minimum. And in order to find any maxima or minima, we have to go ahead, find an equation, derive that equation, let it equal to 0, and solve, and then test those values that we get to see which one is going to give the required minima or maxima. In this case, we're required to prove or find the value such that it's the area is a minima. So let's go ahead and do that. First up, area of that purple concrete path would be found by doing the overall rectangle area, which is x times y, minus this green area, which is 50. We can't have two variables because we can only derive with respect to one variable. And so what we do is, we remember that in the previous part, we proved that y equals to 50 over x minus 2 plus 1. So what we'll do is we'll plug that in. That way we're only working with one variable, that being the x, since the question asks for x anyways. So let's do that. Now we go ahead and expand. And now we're ready to derive. So remember, this one here is a fraction, so we're going to need to use the quotient rule. And that is u dash v minus v dash u all over v squared. And remember, the top is going to be u and the bottom is going to be v. And I'll write that in a different color so you can follow along. So u dash would be 50, v written as is, minus v dash, which is 1, u, which is written as it is, all over v squared. And then the derivative of x is 1, the derivative of any constant is 0, so we leave that out. So a dash equals to 50x minus 100 minus 50x over x minus 2 all squared, and then we've got the plus 1 there. That goes with that, and so we get a dash as being minus 100 over x minus 2 all squared plus 1. So now in order to find the stationary points, we have to let a dash equals to 0. And yes, we have to write stationary points. And so minus 100 over x minus 2 all squared plus 1 equals to 0. When you solve that, you get when you cross multiply that all the way up here, you get minus 100 equals to minus x minus 2 all squared. Divide both sides by minus 1, and that actually gets rid of the minuses. And so that will give us x minus 2 all squared equals to 100. Now, square root both sides. Of course, that's going to be plus or minus the root. That's going to give us x minus 2 equals to plus or minus 10. And so, therefore, one solution is going to be 2 plus 10, which equals to 12, or 2 minus 10, which equals to minus 8. Now remember, x is a length in meters, so the minus is not going to be applicable, and so x is going to have to be 12. But now we have to prove that that's going to give a minimum area. So let's get rid of all of this, and we will keep the derived equation because that is the most important for us. Get rid of all of that now. Knowing that x has to equal to 12. Since we said that x equals to 12 and that our derived equation is a dash equals to minus 100 over x minus 2 all squared plus 1, the way that we will make sure or prove that this is going to give us a minimum area is by finding a double dash. And so again, when we come to this, we have to use the quotient rule once more, which is u dash v minus v dash u all over v squared. And so u dash v minus v dash, we have to use the chain rule, u all over v squared will be our answer. So that's going to be 0 plus 100 to x minus 4 all over x minus 2 all to the 4. And so now what we do is we have to plug in our 12 is greater than 0. So because a double dash is greater than 0, therefore x equals to 12 meters will give a minimum area. And that is how to solve this question.